Today we are going to start with the serverless with AWS. So we'll see what is the serverless and how the serverless concept will be achieved using AWS services. Okay, so before that, let's go with what is serverless, and let's see how the serverless works, how the serverless architecture works. Okay. So what is serverless? So serverless is a new concept in which the developers don't have to manage servers anymore. Okay, so that means the developers, till now what we are doing is we are procuring some servers. Okay, we are launching some EC2 instances, RDS databases, and we are installing all our applications. We are deploying all our applications there, and then we are managing our applications in those architectures. Okay, so but in serverless, we will we will not manage any servers. Okay, but we will run our applications, but we will not manage any servers. Okay, so that means how we will manage is that we just deploy our code. So finally, our output should be we must run our application, or we must run our code seamlessly. Okay, so that might be in a servers. Okay, so if that is possible without maintaining the servers, okay, so that we can also do with that. So that is how this serverless concept came into light. So that in the serverless, just we deploy the code. That means the code is nothing but the functions, or the functions in the code, right? So if you are writing any Node.js APIs, okay, so what we done is we are writing some controllers, and then we are connecting from that models to, and we are to some databases, and from the database we are fetching some data and we are showing it. Okay, when you call a get API, so when you do a post API, what we are doing, so we are sending some data to the function, and that function will send that data to some database, and it will store the data in the database. So end of the day, so what we are running is when you call an API or like when you trigger an API, so what we are doing is we are running some functions inside the code. So that functions, okay, so here in serverless what we'll do is we'll directly deploy that functions in our AWS serverless architecture. Okay, so initially it is called serverless, then it is called as function as a service. So we have seen infrastructure as a service in AWS, right? Okay, so on software as a service. Okay, similarly this serverless architecture is called functions as a service. That means we'll deploy our functions in the AWS, and AWS will take care of the load and all to run that functions. Okay, so whenever there is a load, so AWS will take care of all the servers which will run in the background. Okay, so serverless was pointed by AWS Lambda, but now also include anything that is managed. Okay, so initially serverless was started by AWS Lambda. That means AWS Lambda will be running some functions, running some piece of codes. Okay, so initially AWS started with a Lambda, which includes now there is databases which are serverless, messaging queues which are serverless, and storage is there which is serverless. Okay, so the point is serverless does not mean there are no servers. So there are servers, but we are not managing them. Okay, it means you just don't manage them or provision them and see them, but in the background they will be running in some servers, but we are not managing those servers. Okay, similar like RDBMS. Okay, so RDS, we have seen about RDS database. Okay, so in the RDS database, we are not managing any servers. Okay, but we are just deploying a database there. So we are running or starting a database there, and based on the load, so in the background, so RDS will take care of all the servers that needed to provide that load. Okay, so similarly in the serverless architecture, that might be in Lambda or anything. So what happens is in the background, the AWS will start run this code in some servers, but we don't need to manage or provision that servers. Okay, AWS will take care of that, but it will give us a best output without any downtime. Okay, so this is about serverless. So how the serverless in AWS works? So what are the different serverless services that are being provided by AWS? The first main thing is AWS Lambda, okay, and there is a DB which is called a DynamoDB. This is something like a NoSQL database. That means like it won't act something like a relational database, okay. So DynamoDB is a serverless DB, okay, and AWS Cognito is used for the authentication of users, okay. So whenever a users log into an application, then we can store our user data, okay, store our user base or user master data in AWS Cognito. And whenever a user log in with a username password, we can check that username password is registered in AWS Cognito or not, and then based on that we can provide an authentication to our application, okay. So in the conventional applications, okay, what happens is like they will store mostly like present also they are using the same thing. So when you are using your own database, okay, so what we'll do whenever a user register, okay, so in our I think the previous example also I think we have done. So whenever we fill a registration form and click on register, so what we are doing is we are storing our user details in our users table, okay, in RDBMS. So whenever you are trying to log in, so we are selecting that username password, okay, we are checking that username password is available in the user table, and if it is available in the table, we are authenticating him as a authenticated user, and we are giving authentication to access the other pages in the application, okay. Similarly, this Cognito, what it will do is like we can register our users in the Cognito, okay, using AWS SDK. We can connect to this Cognito, okay, and we can use this Cognito in our application. So whenever we fill an application form, so we will store the data in this Cognito instead of storing them in users DB table. So whenever we click on login, so giving the username and password, it will check in the Cognito for that user. If that user is available, it sends us a success response, and from that like we can move to the other pages in the web application, okay. So similarly, AWS API Gateway. So API Gateways is a powerful serverless feature, so where like we will use to create our HTTPS, and we will see this API Gateway in hands-on in our coming class, okay. So AWS S3 is also serverless because we are storing the file, but we don't know like where we are storing, okay. And SNS and SQS are like notification services, and Kinesis is a data pipeline or data flow, okay, in AWS. Like we can send some data to AWS Kinesis and we can process it. AWS Aurora services or Aurora serverless, we have something like this, and stub functions and fragment, okay. So these are the serverless services which is being provided by the AWS, okay. So in this like we will mainly concentrate on this API Gateway Lambda, okay. So these are something like where we get a lot of questions, and these are like more important concepts in AWS. So you can go through them one by one, in like you can Google it one by one, and you can study more elaborately with them, like how they work and what are the uses of the services in AWS, okay. So why we are using AWS Lambda? So we have EC2 instances, okay. Then other than EC2 instances, why we are using AWS Lambda? So first we will see why and how we use Amazon EC2 in our in our application. So what are the use cases where we use AWS EC2 and AWS Amazon Lambda? So coming to EC2, it is a virtual server in cloud, so we all know that. So it is limited by the RAM and CPU. So if you are using an instance, so it has a certain RAM and certain CPU. So if you do any operations beyond the RAM and CPU, so the server or the instance may go down, so or else it may give you less performance, okay. So whenever your application scales, you need to scale your RAM and CPU. That means you need to upgrade your instance. So it should be continuously running. So once you take an AWS EC2 and you deploy your application in EC2 instance, so you need to continuously run that EC2 instance to keep your application, okay, online. So if you stop this EC2 instance, and the application will also stop. Okay, so in EC2, scaling means intervention to add or remove servers. So whenever you want to scale your applications which are in EC2 servers, you must either, okay, you must scale your servers. Okay, so this is how this EC2 works. So you all know about this EC2 servers. So coming to AWS Lambda, so here we are putting our functions in a virtual server. So we don't know where the server is. We are putting some functions. We are writing a piece of code which we want to execute, and we are deploying that code. So here we are not managing any servers. So no servers to manage. So limit by time. So we no need to. So limit by time, like so here, like we are running a function for almost like 1 or 2 seconds or 3 seconds. So we are just running a limited by time there. When we have a short executions, say like we have a REST APIs and a short execution codes that need to be run, so we are putting them in the AWS Lambda. So if you have long running works which takes like hours, so then you need to go to AWS EC2. Okay, so when you have a short time or a short execution code, then you need to prefer Lambda. Okay, and this run on demand. That means like whenever this functions is being triggered and this function is running, so then only the servers will be charged. Okay, so we don't need to keep all the servers like running to keep this your application running. So whenever you want to run these functions, then only it will, for that time only it will be charged, and it scales automatically because like AWS will take care of all the executions and all the servers related headaches, so that like you don't need to worry about like the scaling part. So if the load is high, then AWS will automatically procure the servers in the background, and it will keep it highly available. So you don't need to worry about high availability and scaling. Okay, so that is the difference between EC2 and Lambda. So one main thing you need to keep in mind is, so if you are running any tasks or any code which runs for a long time, that means it takes hours to run that script, or it takes like hours to process any files. So that type of operations you need to go with EC2. For short execution codes, so say like when you call an API, it goes to database and it retrieves, and it will send a response to using REST APIs. So REST APIs will mostly take like 1 second maximum, like 1 or 2 seconds. So those things, or if you put any item in a bucket, okay, so then that item need to be copied to any other bucket. So that is a short term execution. So for such executions, for such requirements, we use AWS Lambda. Okay, so benefits of AWS Lambda. So it is, first thing is, it is easy paying. So how this pricing happens in AWS Lambda is, so we'll pay per request and compute time. So when you put a request in AWS Lambda to run the piece of function, so it will take a certain amount of time, and it takes some for the completion of that function. Okay, so when you do a request to Lambda, we need to pay for a request, for each request, and for the compute time. So how much time it is taking to, okay, complete or compute that particular piece of code. Okay, so and the good thing in AWS Lambda is in the free tier. So for the starting 1 million AWS Lambda request, we no need to pay anything. So 1 million is huge, and for 400 GBs of compute time, GB, this S means seconds, so 400 GB seconds of compute time, so we can use this in the free tier. Okay, so if you launch any application, okay, so then you will get 1 million AWS Lambda request free. Okay, so integrated with the whole AWS suite of services, and so Lambda is integrated with most of the services in AWS, so that you can get better use of this AWS services and build your application. Okay, integrated with many programming languages. So this Lambda, we are saying like we need to write a piece of code and we need to run it. So that code we can be that will be supported by many like popular programming languages. We'll see what are those languages also. And it is easy to monitor through AWS CloudWatch. So we can see like how many requests we are getting, how much compute time it is being taken, so what is the peak load when it is getting. So all these things we can monitor using AWS CloudWatch logs, okay, for AWS Lambda requests. So it is easy to get more resource per function, okay. So whenever you want to increase the resource for these functions, so you want to make these functions highly available and run fast, then you can scale automatically. You have some predefined configuration where you can update your RAM from up to 10 GB of RAM, you can update it. So increasing RAM will also improve CPU and network. So that means if you increase the RAM size, it will automatically increase the CPU and the network throughput, okay. So this will give you a better output whenever there is a peak load on your AWS Lambda function, okay. So what are the languages that are supported by AWS Lambda? First thing is Node.js, Python, Java, C, C Sharp, and the C Sharp for the PowerShell, and Go language and Ruby. So these are the programming languages that is being supported by the AWS Lambda. So you can write a piece of code in any of these languages and you can deploy them and you can run them in AWS Lambda, okay. So what are we already said, AWS Lambda is integrated with many of these services in AWS. So these are the main ones where AWS Lambda is integrated with. So we can integrate AWS Lambda with API gateways, Kinesis for data streaming, so API gateways to write REST APIs, DynamoDB to store the DB, S3 to store our whenever there is a object creation or deletion in S3, we can trigger a Lambda function and do something, okay. So we can use CloudFront, we can use CloudWatch event logs, okay, and we can use this notification services. So whenever a notification occurs, we can trigger a Lambda function. So and whenever a item is put in an SQS queue, so we can trigger a Lambda function. So whenever if you want to connect to AWS Cognito, and we can get the user's data from the Cognito, and you can use this as an authentication APIs. So these are some services where we can integrate our Lambda and we can use them in AWS. So we'll go for we'll see how the serverless will create work. For example, say you are placing or you are uploading an image in S3, and that need to be pushing to other sub functions or sub tasks that need to be happen. So what we'll do is, so whenever you upload an image in an S3, so we can trigger a Lambda function. We know we have some S3 event notification that is present in S3. So in that event, we can trigger a Lambda function. So when you upload a image to S3 bucket, you can trigger a Lambda function. So this Lambda functions will do, so one thing is it will push the image, and it will, so this Lambda function will convert. So you can write a Lambda function which creates a thumbnail. So that means it takes this image which is uploaded in the S3, and it will convert the image into some thumbnail, and probably it may store it in other S3 bucket. So you can do that. Another thing is, when you put a object in S3 bucket, then you can trigger a Lambda function, so that will add a data of this image in a DynamoDB database, okay. So it takes the metadata, we can take the metadata of this image which is uploaded, and we can send it to this Lambda, and Lambda will store the data in this particular DynamoDB. So saying what is the image name, what is the image size, so what is the creation date of this image. So all this data, metadata, you can store it in DynamoDB. So you can trigger some events, okay, with the AWS Lambda, okay. So, and you can also provide serverless cron jobs, okay. You can also deploy serverless cron job using Lambda. So cron job is something if you are familiar with Linux, you will be understanding this. So cron is nothing but scheduling some tasks. So say if you want to run any code for every 1 hour or every so every day morning at 6 o'clock or every Monday. So there are like different patterns using cron jobs. So if you want to run any scheduled tasks, okay, then you can create the schedule in the CloudWatch event bridge, and this CloudWatch event bridge will check the tasks which are being scheduled, and for every task or every schedule you can trigger a Lambda function, and this Lambda function will be performing this tasks. So you can schedule a task for every 1 hour here. So in the CloudWatch, if you trigger a job, say like for every 1 hour you need to do this. So for every 1 hour we'll create a CloudWatch event, and for that every 1 hour we'll keep this target as this Lambda function, and this Lambda function will execute the code for every 1 hour. Okay. So as I said, like Lambda pricing, an example. So you can find all this pricing in this particular link. So if you go to AWS Lambda, you will get a column called pricing, and there you can see the pricing. So how this works is, first we need to pay per calls. As we said, we need to pay for each call which we request to the AWS Lambda. So and first 1 million calls are free. So that means after 1 million calls you will get other 1 million requests for just 20 cents. Okay, so this is like very cheap when compared to EC2 instances. Okay, so how this durations works, like how we'll pay for the duration means, so initially they will give like 400, so 4 million GB seconds of compute time per GB per month for free. For every month you will get this. Okay, so if you are using 400,000 GB seconds, so then if you are using like 1 GB RAM, you will get 4000 GB seconds. So if you want to reduce the RAM, so if you can reduce the RAM to 128 MB, okay, so then you will get like this many seconds of function. If you increase the RAM, so this second may decrease. So based on the, so if you increase this RAM, this second may decrease. So based on the compute size, okay, this will be defined. Okay, so it is usually very cheap to run AWS Lambda, so it is very popular. So that's why AWS Lambda is very popular. Okay, so we'll see how this AWS Lambda works. So, and one more example is like where you use Lambda is like you are a student or something, or you are an initial startup, you are running an initial startup, and you have created a mobile application. So you don't know how much it scales. You have an idea and you created a mobile application, but you don't want to spend much money, okay, on hosting this. So you don't, if you procure an EC2 instance, and if you take it and if you deploy the application in EC2 instance, if your application runs or not, say like you have created some mobile app on with your own idea, okay, you don't know how much like it will get popular. Either it may spread across the people and may get popular, or like nobody will use it. We don't know how much like the traffic will get into it. Okay, so at that time, if you use an EC2 instance, so if the application is running or not, if your application become popular or not, you definitely need to pay for the EC2 instance. So at that time, if you come to this AWS Lambda, so whenever an application is being used or whenever the requests are getting used, then only you will pay for that calls. So if your application is not being used by anyone, or it is being less used, you will get less cost, okay, less bill. So if your application is going more, okay, if your application is going more popular, and like so many users are coming to your applications, then this particular, once again, okay, so then if your application got popular, then if you are getting more requests, then you will pay for those requests only. Okay, so we'll see how this Lambda will be in AWS console. So we'll go to AWS console first. Okay, so the search will go with So lambda. So when you open this, you will get a page like this. So you will get an intro. So this will be a cool intro. So here if you see, so how it works is like it supports all these particular programming languages. So here we can write a code like this. So these are the functions which we are writing in our code and deploying in EC2 instance. Okay, so those functions you can directly write here and you can run this code. So if you run this code, see it is printing hello from lambda. So here we are writing a function and here we are returning hello from lambda. Okay, so it will execute this piece of code only. So when you put a request lambda, okay, so if you go here, so here we have a cool example here. Say like we are using some data streams, so that data streams you can send the data to lambda function and it will execute here. Okay, so if you have a photo, if you can upload that, if you upload a data in a S3 bucket, so it can trigger a lambda function and you can do an operation, okay, with that. So you can do that operation with that event. So whenever you put a data in your S3 bucket, it can trigger a lambda function, you can do something. So whenever you get a message from some mobile to your mobile gateway or any APIs, so then you can trigger a lambda function and you can, okay, run that lambda function and you can do whatever, like whatever you want with that message. So best thing in this is like if you, so whenever, like if you increase the load, okay, so if you increase the load on your S3, okay, so and this, for each event it will trigger the lambda function, and if you can see here, like the lambda function will procure the servers in the background and it will take care of all that. Like we no need to worry about the servers. The more data it receives, the more servers it procures and it will run. Okay, so this is how this lambda works. So whenever you create a something, whenever you based on the event, you can create a lambda, and whenever that lambda function is called, it will execute that and it will give us a response. Okay, so it will scale seamlessly. So say like here initially we are like putting some requests, and here see these invocations are being increased. Okay, so for first 1 million we won't get any charge here. So see, so after that 1 million, so the cost will be starting for every month. So it is very cost effective. So either like now we have done almost like 3 million requests and we are just charged only 50 cents or 43 cents. It's okay, for 3 million, 3.5 million requests we are just charged only, okay, half cent. So here this is very cost effective. Okay, so just now like we'll create a sample function and see like how it works. So to create that, just click on create function. So you will get something like this. So either you can write it from scratch or you can take it from a blueprint. So there are some blueprint, that means like predefined functions. Okay, so for now like I'll select this node.js hello world function and I'll say this as my demo lambda function. Okay, so we'll leave all this. So this is the template. So here what is doing is it's like printing 3 variables and it is returning a variable here. So we'll just create this function. So this will create a function in our lambda and it will take care of all the servers related, okay, architecture in the background. So it will take care of all the servers. We just need to create the function, that's it. So here our lambda function is created, and if you come here you can see here is our function. So if you want to test this, you can click on test and you can create a test event. I'll call this as my test sample. Okay, so and here we'll save this. So this is the JSON that is being sent with the event. Okay, so here we are sending some JSON to the event, and in this we have key1, key2, key3 values. Okay, and we'll save this, and now if you run this, see, so it is executing this code and it is sending the response as value 1. So here we are sending a return event key1. So event is something which we are data which we sent from our request, and event.key1 is this value 1, right? So it is sending that data. And here it is, see, it is printing all the logs here. So we have written console.log for this 3, and it is printing these 3 logs. And here it is taking 2.28 milliseconds of duration to run this function, and the build duration is for 3 minutes. So it will seal the duration time and will build that. So 3 milliseconds has been taken. Okay, and the memory size is 128 GB, which we are running, and used is 57 MB. Okay, so we'll get some each request twice we will get some data here, and the main thing is we'll get a data here. So if you change this to, say, like here I'll return some JSON variable. So if you say like data, and if you put some array here, okay, and if you just deploy, so whenever you change the code in this Lambda, you need to deploy it again, so it will replace the function. And if you test it now, see, we are getting the response here. So it is just like we have not procured any servers, we have not done any configurations, we have not installed any softwares, Node.js softwares. Okay, so we haven't write any Node.js related initial functions. We have just written a code here, so that is being executed and we are getting the response. Okay, so this is how it works. And if you go here and monitor, so you can see the monitoring part here. So here you can see like how many requests you are getting on each day or each time. So how many requests you are getting, how much duration it is taking to run that particular code, and if there any occurs, that is events, errors and all. So here you can see what are the concurrent executions and everything. So you can identify, so at what time we are getting a like high number of requests, and what time for what function it is taking, like for the function when it is taking a high duration, you can check it here. So you can monitor all this metrics here. So if you go to logs here, it will also be creating a logs for each. So for each Lambda function it will create logs. Okay, so this configuration, so this is one of the important part. So if you want to increase, as we said, if we can increase the RAM size of this function, so it's Lambda function to execute, so that we can do it here. So you can edit the memory. So now it is by default using 128 MB of RAM. Okay, so if you can edit it and you can increase it up to 10 GB. Okay, so the more RAM you use, so like you will be reduce the execution seconds will be decreased. Okay, so and the execution time will be decreased, and that's it. So if you go to logs here, one more thing. So if you go to our monitoring here, and if you go to logs, and if you click on this view CloudWatch logs, okay, so these logs will be stored in the CloudWatch. So here see, so whenever we create a Lambda function, so initial by default it will create a log group with that Lambda function. So it will create like AWS Lambda with a Lambda function, it will create a log groups in the CloudWatch. So CloudWatch is something, it will create, or it will like handle all the logs, and it will monitor all the services. Okay, so here there are 2 logs that is being created. So if I open this log, so see here, like we'll get all the log that is related to our Lambda function. Okay, so if you take another log, so this is something, the log which is being printed with the functions. If you have any errors in that Lambda function, for example, if you go to this Lambda function again, the code, and instead of this, so instead of returning this, if you throw an error, so here we can throw an exception. So deploy it again, and if you test it, so it is sending some error. Okay, so if you go to this CloudWatch logs again, and if you refresh this, we need to go to the latest log. So if you go to this, the latest log is this one, right? So see here, we got that error here. So it is saying that error, something went wrong. So we can see that error in that CloudWatch. So using CloudWatch, you can monitor the logs of your Lambda functions. Okay. So whenever you got some errors, then you can check it here and you can go to Lambda function and you can resolve it by changing your code. Okay. So this is how this Lambda function works. But like here we are simply writing a Lambda function, but we need to know how to run it. So every time we won't come and test it here, right? So we need to trigger it from somewhere. Okay, or so there must be some event that might be calling this Lambda function and making this run, right? So we'll see about that. Coming to our slides. So this is about Lambda. So you need to understand so apart from this hands-on session on Lambda, you need to just understand the concept, like how this Lambda works and what is this Lambda, and in which use cases we'll use this Lambda. So that are the things you need to keep in mind for solutions architect. If you are a AWS developer, then you need to understand like how this Lambda function will be created, how we must write the code. So all these things we need to know if you are a AWS developer. So if you are an architect, you need to just understand when and how this Lambda works and what are the cost effective things, that like how we can reduce the cost using Lambda if you are running an application. So is my application or is my requirement will be, if my architecture can provide best output with low cost when you use Lambda. Okay, so all these things you need to figure out if you are an AWS architect. Okay, so the next thing is AWS API gateways. So AWS plus AWS API gateways. Okay, so this will create a no infrastructure to manage. So it will create a like REST APIs and all that we cannot, we don't need to create any servers, we don't need to maintain any or manage any infrastructure. Okay, so this API gateway supports for WebSocket protocols also. Okay, and it handles API versionings, and it handles different environments. So you can create development environment, test environment, production environment for this using this API gateway. So API gateways is nothing but they are endpoints. So for example, if you create a REST API, so what we'll say, like we will create some URLs, right, saying like some www.something.com/get users or post users or get the list of subjects. So those endpoints we can create in AWS API Gateway. So this can be handled in different environments: development, test, and production environments. It handles its own security. Okay, so it creates API keys and handles the request throttling. So it will use something like Swagger or OpenAPI import to quickly define APIs. You can define your APIs in Swagger or OpenAPI, and you can import those APIs in our AWS API Gateway, and it will create a gateway for them. So those Swagger and OpenAPIs are like open tools to create these REST APIs. Okay, so you can transform and validate request and response. So what are the request and response that are coming into or going out from this API gateway? So you can validate them. You can connect this API gateway using SDKs. You can generate SDKs and API specifications, and these APIs can also get cached. So you just understand, like API gateways are something which provides some URLs, and when you call that URLs, you can trigger some functions. Okay, similarly like a REST API. Okay, so high level integration, we'll see about API gateway. So we can integrate this API gateways with Lambda function. So you can invoke a Lambda function whenever you call an API gateway. So these two combinations will easy way to expose REST APIs backend by AWS Lambda. So you can create any REST APIs using API gateway and Lambda functions. Okay, and you can also integrate API gateway with HTTP protocols, so HTTP endpoints. So you can use HTTP endpoints in the backend. For example, like internal HTTP APIs, on-premises database or on-premises applications or load balancers, you can create this API gateway. Okay, So you can expose them to many other AWS services. So expose any AWS API through any API gateway. For example, is you start an AWS step function. So we'll see what is step functions. So you can start an AWS step functions, or you can post a message to SQS queue, okay, or you can send some emails or something, and everything you can do with API gateway with the AWS, and you can connect or integrate with AWS services. Okay, so these are some like use cases where you use API gateway and integrate them in high level. So you can understand here. So we'll see how this API gateway works. So for example, we'll see that AWS service integration with Kinesis. We'll integrate API gateway with the AWS Kinesis data stream, and we'll see how it works. So say like we have a client and it requests the API gateway and it sums some data to API gateway. So then the API gateway can trigger or send the data to Kinesis data stream. So Kinesis data stream is something like which receives the pool of data which is being sent from any of the client, and it will process the data and it will trigger the data to other Kinesis firehorse. Okay, so whenever the request comes to API gateway, the API gateway can send the data to Kinesis, and Kinesis will collect all the records and it will process them, or it will send it to the a firehouse, and it will create some JSON files here, and the JSON files will be stored in this Amazon S3. So data which is being sent by the client is in the end stored in S3 as a JSON file. So this can be sent through API gateway, and API gateway can trigger all this, and this can be stored here. Okay. Another thing is you can create a REST API using AWS gateway. So whenever the client calls a REST API, you can run that, you can take the request and you can take the data and you can send it to a Lambda function. So Lambda function will execute the code and it will put the data in some DynamoDB. So whenever you call a REST API to get the data, again the API gateway do a get call, and this get call will be triggered a Lambda function, and this Lambda function will connect to DynamoDB and get the data, and it will give back the data to this client. So this is something like a request and response. You request the API gateway, it triggers the Lambda function. A Lambda function gets the data from DynamoDB and provides that data to the end user. So this is how we create a REST API. So anyway, we'll see this how we'll see this in the hands-on. Okay. So API gateway endpoint. So there are three types of endpoints in API while creating an API gateway. So one is edge optimized. This is default, okay, endpoint. So this comes as a default option. So in this edge optimized, what it will do is the requests are routed through the CloudFront edge locations. So that means we already seen in the CloudFront the data will be cached in the edge locations. Okay, in the AWS global infrastructure there are edge locations, right? So in that edge locations the data will be this data will be routed through the edge location, so that like it will give the end users less latency, and it will give the faster response. Okay, so that API gateway still lives in one region. So the API gateway which we are creating, that will be in one region where we are created, but the response will be spread across the world or across the globe using this CloudFront edge locations. Okay, and there are something like regional endpoints. So regional endpoints, like if your application is confined to a particular area, say like your application will be used only in India or only in Asia or only in US, so you can put a regional endpoint. So then that particular API gateway scope will be transferred only within the region. Okay, so when you are using a region specific application, then you can go with this regional endpoint. And we have a private endpoints. So as the name suggests, this can be only accessed from your VPC using a interface or ENI. So uses a resource policy to define the access. So when you want to access your APIs, okay, or the gateways only in your private VPC, so then you will go with this private endpoint type. Okay, so we'll see how this AWS Gateway works in AWS console. So here we have our AWS console. So here we have our AWS console. So we'll search for API Gateway. So here we have API Gateway. So here we have different types of APIs, API gateway. So first thing is like HTTP gateways. So WebSocket API, we have REST APIs and REST APIs private. So we can go with this. So if you see, like each type of API works with different types of AWS services. If you go with HTTP API, it works with Lambda and HTTP backends. If you go with WebSocket, so this is something, WebSocket is something like chatbots and chat applications. So we'll create a WebSocket APIs, and these are the REST APIs which we used. So these are the REST APIs which we create in the private VPC. So for our example, we'll go with REST APIs because we are familiar with this. So we'll go and build, click on build. So this will give a screen like this. So close this. So now we are creating a REST API. So here we have an example API. We'll go with a new API to see these options. So here create a new API. Here we'll get the API name. So first thing, my demo API. So here I'm giving the API name, and you can give some descriptions here. And here we have seen what are these endpoints. So by default, like it will be this regional. So that means like if you are confined to if your code is confined to this any particular region, then you can select this endpoint. So if your code is like that might run globally, like there are global users which are using this code, then you can go with edge optimized. So I'll go with the regional and just create an API. So we created a REST API, and here we'll get a screen like this. So what we'll do is, you can create some actions in this API gateway. So here I'll create a method. So here I'll get this. So I'll create a get method. We are creating a REST API. So I'll create a get method, and I'll save this. So a get method is created. So the integration type. So what it should trigger here. So what I'll say is, so whenever I call this API gateway, in this API gateway, whenever I call this get function, so I need to so this is my get function. So then I need to trigger a Lambda function, or I can trigger a HTTP endpoint. So I can call any other AWS services in any region. So I can call any of these AWS services. You can use any of the services. So for now we'll go with Lambda. So whenever I trigger my endpoint, so whenever I trigger my API gateway, it should trigger a Lambda function. So and here I need to give my Lambda function name. So already I have created a Lambda function here in our previous session. While creating a Lambda, while discussing about Lambda, we have created this Lambda function, right? So or else you can go to this and you can create a, so I'll go to this Lambda here. So we have already created a function. So what I'll do is, I'll just comment this throwing error, and I'll return this data. So in this Lambda function is just returning some data. So I have made some changes, so I'll deploy it again. So now my Lambda function is ready. So the Lambda function means this Lambda function gives this particular response, right? So my Lambda function is ready. So I'll go here, and here I'll select this Lambda function. So whenever I call this API gateway, so this will trigger this Lambda function. So I'll save this here. So add this permission. So here this API gateway needs to access the Lambda function. So it is asking to add permissions. So it is saying that you are about to give API gateway permissions to invoke Lambda functions. So you want to accept. So then if you click on OK, it will automatically create that policy. So you don't need to go and create a manual policies. So here we have created a get call, and if you and this, so this method will integrate with a lambda. So whenever you do is this call, this will trigger a lambda function. So this lambda function will be executed, my demo lambda function, and it will give the response to this particular lambda function, and this lambda function will throw this response to our API gateway, and this API gateway will give the response to the client. So it will show us the complete life cycle, how it works. So if you click on test here, it will take to this page, and if you click on test here, see, now we are getting this data here. So now we just created a API gateway endpoint, and we created action, and this action we are creating a method, get method, and this get method is triggering a lambda function, and we are getting the response from the lambda function, and the status is 0 and the root is /, and you can write something like get students or something. So by default, like I have taken this as /. So if you want to edit this, so you can go to this get function, and you can, or else you can add another function. So if you test this, it will give something like this. Okay, so now we have created a API gateway, and this API gateway is triggering a lambda function, and this lambda function is returning this data. So I want to use this API, REST API in my applications. Okay, for that I need to get a URL, right? You need to get an API URL. On that URL only you can, then only you can put that URL in some your Angular code, and you can do some HTTP call, and you will call the data and get the response. So to do that, what we'll do is, so we go to the actions again, and here you will get a option called deploy API. Okay, we'll write another get method also. Okay, we'll deploy the API. So if you click on deploy API, it will ask the development stage. So what is this deployment stage? You can create a new stage, and the stage name is something like dev stage. Okay, you can deploy it in a development stage. So see, after creating this, it has provided us a URL here. So if you take this URL here, copy this, open a browser and paste it here. See, so now we are getting an API, get API. So we have created a get API, and we are getting this data. So whenever you create any other actions in this API gateway, this particular endpoint will be same. So you can use this particular endpoint, and you can change the roots here, and you can write different APIs. Okay, you can take this API, and you can put it in your Angular code, and you can call this API, and you will get this data, and you can use the data. So now see, simply like we have created a lambda function, and we have created an API gateway, and we pointed this API gateway to this lambda function, and we are getting this data. So here we didn't create any EC2 instance, we didn't install any Node.js software in our instance. Okay, we haven't write any npm install, or we haven't imported any npm packages. Okay, everything that is being run by the AWS Lambda. So AWS Lambda is taking care of all that. Okay, environment. So it just create an environment to run your code. You just write your code and run it. Okay, and you can join it to your API gateway, and here like we'll create a API endpoints. So similarly, you can create any number of endpoints here. So you can create any number of endpoints, and you can use them. Okay. So if you go to resource again, you can create some method. So now you can create a post method, and in this post method you can send some data. Okay, so the data will be received on the lambda function, and that will store some data in the DynamoDB or something, or you can store them in RDS or something. So like this you can define all your API calls. Okay, so this is how this API gateway works. Hope you understand this. And there are other few concepts, so there won't be any hands-on session for that concept, but you need to know this concept. Okay, So that is Cognito. So Cognito, in the brief I have explained this in the previous slides. I have explained a brief about this. So Amazon Cognito is like it gives users an identity to interact with our web or mobile applications. If you want to store any users data over your mobile or web application, other than storing them in RDS or any other databases, you can use this Cognito. So Cognito user pools. So what this Cognito user pools is the sign-in functionality for app users. This will provide, and it integrate with API Gateway and application load balancer. So you can integrate this with these two AWS services. So Cognito identity pools, federated identity. So this is one more thing, like provide AWS credential to users so that they can access AWS resource directly. So if your users want to access the AWS resource which is in the AWS console, so in the Cognito users pool they are using external applications, so not the AWS services. Okay, so in this Cognito identity pools, your users can access the AWS resource directly from their applications. Okay, through Amazon Cognito. So Cognito integrated with user pools as an identity provider. So how this Cognito works other than IAM? So if you have hundreds of users, okay, so say like if you have like limited users, you can create a IAM role and you can create IAM rosters. But if you have hundreds of users, or they are using mobile users or authenticate with SAML, so if you find any of these keywords in the questions, so then you can say we can use Cognito. So based on these keywords, like you can suggest this Cognito. So what are Cognito user pools and what are the users and user futures? So Cognito, using this Cognito user pools, we call it as CUP. So you can create a serverless database of your users for your web and mobile application. So you don't need to create a database or store the users data in that database. You can push those users data to Cognito, and this Cognito will store them and it will authenticate them. So it will create a simple login with a username, that may be our email, and a password combination. So when you create this and again when you want to log in, you just pass this username and password, and it will authenticate that user and it will give you response. And it have all the options, like you can password reset option will be there, and email and phone number verification options, and multi-factor authentication, and even it support third-party identities, like if you want to log in with Facebook or Google. Okay, so it will give the access for that particular options also. Okay, so we'll see how this CUP integrations will be done in AWS. For example, so we can CUP integration, we can do it with API Gateway or application load balancer. So here, say like we have a client system here. So when the client get authentication, so whenever a client do a request or a login request, it will authenticate it from the, so when the client do a REST API call, so first we need to identify whether the user is authenticated or not. So then what it will do is we can connect to Cognito user pools, and this authentication is received. So whenever we get an authentication saying that this particular user is authenticated, then it triggers the API Gateway, and API Gateway will run some backend code and it will give the response, okay, to the client. So this here in this REST application, REST APIs, we can pass the token here. So whenever this user is authenticated, then only it will pass a token to API Gateway. Okay, so and then we will get the response here. So this is like something a authentication for the REST API. So whenever a client system is running through an application load balancer, so this application load balancer also can authenticate the request from the user, Cognito user. So whenever there is an authentication, so then only it goes to the backend and it will get or do the functions in the target groups. Okay, so that's it. Like you need to just study about this AWS Cognito in the AWS documentation. So these are the main things that you need to just remember. So AWS Cognito is used to store the user information, and whenever we have hundreds of users and whenever you have some mobile application users, then we'll go with AWS Cognito. AWS Cognito can be will provide all these options, okay, and AWS Cognito can be integrated with API Gateway to create REST APIs, and it can be integrated with application load balancer. Okay, so these are the things you need to remember. So that's it for today. So we have seen what is Lambda and what are the different features in Lambda, and we have seen what is API Gateway. And one more thing I want to show, I think we have gone with an example. So in the previous example with Lambda, we are triggering an API Gateway and we are calling a Lambda function, right? So here we created API Gateway, and this API Gateway is triggering a Lambda function. Similarly, this Lambda can be integrated with other services also. So I want to show you one more example. Say like I'll go to my Lambda functions again. Okay, here I'll create one more function. So say like I'll create a function saying I'll take a default one, and I'll create this function. You need to provide a name. So what I want to do is, now I'll keep I'll upload an image to an S3 bucket. So whenever I upload an image, so then I need to get the data of that image to this Lambda function. So that here I can do some operations to that image with that image. So what I'll do is I'll create a Lambda function. So AWS S3 Lambda demo. Okay, so we are creating this Lambda function here. So meanwhile I'll go to my AWS S3. So I'll go to my S3 and I'll pick a bucket here. So we have few buckets which I have already created. So I'll go to some bucket. So I'll take this bucket. So here what I'll do is I'll go to this properties. In the properties we have something like event notifications. Okay, so I'll create a new event notification and I'll say AWS Lambda S3. Okay, so I'll leave all this here. So when I want to create on which event I want to create is like for all the all create events. Okay, for all the create events. So whenever the object is created in S3 bucket, I want to trigger this event. So and we'll go here, and here what is the destination. So we are creating an event. So while creating an event, so what it should call. So here I am selecting a Lambda, and here my AWS S3 Lambda function is already created. Okay, so I'll give this. So I can choose a Lambda here, or I can enter the Lambda function here. And so here I'll go to AWS S3 Lambda demo. So whenever a object is created in an S3 bucket, I want to create a trigger event, and that event will trigger this Lambda function. So I'll create a Lambda function here, and I'll save the changes. So what it will do is, here we'll just comment this, or else we can just return the event here, or we'll console.log and we'll print this event. So we are just printing the data which is coming in the event. Okay, so I'll deploy this. Just no need of testing this. So now I'll go to here my bucket. So now here I have created a event notification. Okay, so now what I'll do is I'll go to my objects and I'll upload a file here. So something like this. I'll rename this file saying that S3 upload file. so .jpg. So I'll select this file and I'll upload this. So now I uploaded a file here, and if you go to this AWS Lambda and if you go to monitor and if you go to this logs here and if you go to this CloudWatch logs, so see here it has created a CloudWatch log, and now we got that logs here, and see here, so we got a request from AWS S3 and we got it from AWS S3 what is the region, what is the event time, so what is the event name. So we put an object in that, so we can copy this and we'll paste it here so that we can see it more clearly. So we'll put it we'll paste it here. It's copying the same thing, so we'll do one thing. So we'll go to our AWS Lambda, we'll convert this into string and then we will print it. So we'll go to the code again. So now we'll say JSON dot, so we are getting the option C here. So I'm just converting this into string, the JSON into string, and I'm deploying it again. So I'll put another object here. So I'll upload another image. So I'll upload the same image again. I'll upload it. So my image is uploaded, and if I go to this AWS CloudWatch logs and if I refresh this, so we got another latest log. So we'll open this, and if you open this, see here, so we got all the information of that particular image. So this is the time, so what is the event name, which is put, user identity, this is the like unique key of that particular object. So what is that object name, so see we got this object name. So what is the ARN of that object, what is the size, and what is the version. So all this information it is triggered from the AWS S3 to this Lambda function. So from here, like, you can take this image or you can access this particular image with this ARN and this unique key, and you can put it in other bucket, or you can send it to any other data streams, or you can post it to some other services, AWS services. Okay, so this is how this works. So if you go again and see in this Lambda function here, so if you refresh this, so see here now, so we have a target here. So whenever an S3 uploaded, we have uploaded a image in S3, then this will trigger this Lambda function. Similarly, you can add multiple number of triggers. So whenever you put in another bucket, so then also you can trigger this. Okay, so you can add multiple number of triggers for this Lambda function, and these triggers will be with different AWS services. You can use all these particular AWS services, and based on these services you can trigger. So if you are using any API gateway, then you can trigger this. You are from this load balancer, from this code commit or something. So whenever you can create all these events, and that events can be triggered to this Lambda function. Okay, and this AWS Lambda function also can send this data to any other destination. So you can send this to an SNS topic, you can send it to a queue, or you can call another Lambda function. Okay, you can send this data to any other Lambda function and you can trigger that destination. Okay, so if you create an SNS topic, the topics will come here. So you can send this particular notification saying that an image is uploaded. So whenever image is uploaded into this bucket, if you want to send a mail saying that an image is uploaded in the bucket, so you can do that. Okay, so for that what you will do is you will trigger this particular S3. When your image is uploaded in S3, it will trigger this Lambda function. It will take the data of this image. So we got all the data of that image, and you can send a mail from this Lambda function saying that okay, an image is uploaded in S3 and the name of this image is this one and the size is image this one, the URL is this one. You can send all this data to some queues. Okay, so this is how this Lambda works. You can add multiple number of triggers and multiple number of destinations. Okay, so this is one of the powerful service for the serverless, to build a serverless architecture in AWS. So this is one more example. Hope you understood with these two examples, the API Gateway with Lambda and S3 with Lambda. Fine, if you have any doubts, you can ask me, or else we can close the session for today.